That's good. And I think with that, I would pass it on to Adrian. And after Adrian's section, we should probably have some minutes, maybe 5 to 10 minutes. I'm flexible for questions by the audience. Happy to chat about pretty much everything, but let me hand it off now to Adrian so that he can show you how we can scale that up to multiple GPUs. So this is training on one GPU. It's quite quick because it's just the MNIST dataset, but in the real world, you may have something that is a little bit bigger than MNIST. So Adrian will show you how we, let's say, train networks efficiently using multiple GPUs and other devices. So let me then stop talking and let Adrian take the stage here and tell you all about scaling the code to multiple GPUs.
Yeah, awesome. Thank you so much, Sebastian. So just give me 1 second to switch to the screen here, to my presentation. Oops, that's the wrong one. Okay, almost there. All right. Yeah, awesome. After this awesome PyTorch introduction by Sebastian, you are probably very eager to try PyTorch yourself. And it's going to be a lot of fun. It's very easy to get started, believe me. But as with every project that starts very simple, things can get more complex over time as the project evolves. So in the next few minutes, I want to give you a glimpse at a few challenges that you might face and introduce you to this little library called LightningLite that hopefully helps you overcome these challenges. And with every deep learning project, we usually start with an idea that we somehow need to materialize into code that we can run. And in the end, what we want to do is we want to validate the idea. We want to compare against other people's work. We want to look at the metrics. We want to know whether the performance is good. And if it isn't, we want to reiterate. We want to iterate and go back to the code, change the model. Maybe we need to change the data, add more data. We need to change our optimization algorithm and so on. And we need to rerun a lot of experiments. And in every of these iterations, we want to get to the test phase as fast as possible. Most ideas don't work. It's sad, but that's what it is in research. And we want to know as soon as possible whether something works and or doesn't. So time is very precious here. To accelerate this experimentation phase, we can run on specialized hardware like GPUs or TPUs in the cloud. But to do that, normally we need to invest actually a significant effort adding these capabilities to our code and especially also maintaining it over time as we change the code. And this is just significant engineering that doesn't really have anything to do with the research itself. And the code that you would normally write like this, it looks like this. So this is also what we call sometimes boilerplate code. It is repetitive code. You need to add it even if you don't fully understand it. And it doesn't have anything to do with the science of your research, but it needs to be there. And also very important, it adds like an attack surface for bugs. So you spend quite a lot of time debugging this code that you don't really understand usually. So this is not very pleasant for beginners, and that's where beginners get stuck a lot. And here is just another example of some code that you would have to write to when you want to use actually multiple GPU devices. And if you don't add it, actually there is actually no error in this case here. This is about splitting data across multiple devices. If you don't do that, actually you don't get the benefit of multi-GPU. So these are these weird cases where there's not really an error, but actually you don't get the benefit of the accelerated hardware. So this is very hard to debug for beginners. So why did I show you this? Well, I basically want to introduce you to some tools, LightningLite, and what can LightningLite do for us here? Well, it basically handles all this boilerplate for you. And so that you can actually focus on what matters, the research itself, while at the same time making the best use of the hardware resources that you have available. And so in summary, with Lightning, you get you get to run your code on CPU, GPU, TPUs in the cloud, even multiple of these devices together in parallel. You can also even run across multiple nodes, so multiple machines joining together to train a single experiment. And you also get this thing called mixed precision. If you enable it, it actually, on some newer GPUs, it actually performs calculations faster because the neural network computations take place in a lower bit precision, but most importantly, also it saves a lot of memory because the intermediate outputs between the layers of the neural network are in stored in lower bit precision. So these are the benefits of LightningLite if you choose to use it. And I want to just basically show you how we can use that by taking Sebastian's code and convert it to LightningLite. So the first thing we need is the library itself, and LightningLite is part of a bigger library called pytorch-lightning. So to install it, it's very simple. You just type pip install pytorch-lightning, and then you have it. So as I said, we're going to take Sebastian's code and convert it. There's actually not much work to do. So the good news here is that there are no code changes required to the model itself. So we have this PyTorch CNN that he showed us with the convolutional layers and the sequential and everything. We can just take that, copy paste it, no changes required. That's awesome. And also the data code that he skipped, but he has it in the Jupyter notebook. We can just take that, nothing to do there. Usually we would have to write some code without LightningLite, but with LightningLite, we can just take that code, no changes required. Awesome. Now, all the remaining code, the training loop specifically, will go inside of the LightningLite Skeleton. So this is a simple class that you create, and it's a subclass of this LightningLite. So instead of an module that you had for the model, there you have just LightningLite. So it's very similar. And then inside of the run method, you put all the code you want to, let's say, accelerate. So we will actually put in the next slide all the training loop inside of that run method. And then to run it, you just create this class. At the bottom, you see light, and then you run it. And sorry, and once we converted the code, I will actually show you at the end what are the different options you can set inside of Light to choose the hardware you want to run on. So let's take the code that Sebastian had here. So we started by initializing the model and the optimizer, and so we're going to do that here too. So we take the PyTorch CNN, we pass in the number of classes, and then we create the Atom optimizer. And one thing that you will do in LightningLite is set up the model and the optimizer. So this is this line highlighted there, self.setup model optimizer. And And in this setup, LightningLite simply makes sure that the model and the optimizer are compatible with the hardware you want to run on. So it wraps them, it makes sure that everything is set up. And this is nice because from now on, you actually don't need to worry about devices anymore. So all of this gets handled by Light. And so you can actually delete these lines that say model.toDevice or data.toDevice and so on. So that's nice because you don't need to think about it, so you can't really forget about it. And yeah. Then the next thing we want to do is to set up the data loaders. So these two steps are not really necessary in this order. We can do it also in the other way around. But the important thing is that you, for every data loader that you want to use, you call self.setupDataLoader. And this will enable LightningLite to split the data if you're using multiple devices, so you can take advantage of training your model in parallel. This gives a significant speed up, usually. So this is the second step. And then we have to, of course, implement our training loop. So Sebastian showed us that we have these simple two loops. We iterate over the epochs, and then inside of it, we iterate over the actual data samples. And again, here, we can actually delete some code that he wrote, these lines that move the features and the target to the device. It's actually not necessary anymore. If you have it, it doesn't really do anything, but here in Light, actually, the data has already been moved to the device. Every time you iterate over the data, it gets moved automatically. So one less thing to worry about, and one less thing to get wrong, actually. Finally, this is basically the last step here. We need to do one more change. And this is when we compute the forward and the backward process. So the forward pass through the network is actually unchanged. So this is the same code. We pass in the features, get back the logits, we compute the loss, as we always do, just here the cross entropy, for example. And then once we actually compute the gradients, we actually, instead of doing loss.backward, we call self.backward and pass the loss inside. And this way, we let LightningLite actually handle the backward computation. So everything works well on all the hardware, whatever hardware you're running on. And especially this is needed when running in parallel with multiple devices. And I'll show you how you can do that. So these are really all the code changes that we needed to do. And why did we change this code? Well, because we wanted to accelerate our code, right? So now we actually need to tell LightningLite what hardware we want to run on. And if this hardware is actually available on the machine we're running on, it will use that. So by default, everything runs on the CPU if you don't specify anything. If you want to use one GPU, then you basically tell LightningLite, I want the GPU accelerator by saying accelerator equals GPU. It's a simple string. And the nice thing is that there's also a devices attribute that you can set to whatever number of devices you want to use. So if you want to use one, LightningLite will use one. Of course, you need to have a GPU in your machine, but if you have it, it will just use that and everything will work. And if you have multiple GPUs in your computer, you can also set this number then, of course, to whatever value you want there. You can also select specific devices. This is sometimes useful if you run like multiple experiments and one experiment is running on one GPU and another experiment is running on another one. So you give it the actual device ID here. And then it's also very easy to run on TPU now, because all you can do is say accelerator equals TPU, devices equals 8. And then if you're, for example, running this in a Google Colab where you have TPUs available, now this just works. You don't have to change your code to support TPUs. It's just there out of the box. And then a nice thing is also you can set these two attributes also to auto, so that if you just want to run your script or run your model and not worry about on what hardware you are right now, it will just select the fastest hardware that is available on the current machine. So this is very useful. And yeah, as I previously mentioned, there are also some memory savings that you can enable. So by default, everything is in 32-bit precision. This is what PyTorch uses by default. And this is good for most users. But sometimes you actually want to run bigger models, and then you run out of memory. And sometimes what helps is like enabling the mixed precision, so that a part of the neural network, so that some of the computations in the neural networks can actually use less memory and run more efficiently using 16-bit precision. So you can simply enable that in LightningLite by setting this flag, precision equals 16. And yeah, so this is very simple, and also removes a lot of pain and boilerplate code that you would actually have to add to your training loop. Because if you use lower bit precision, what can happen is that sometimes computations become unstable. And so you have to actually add extra code that verifies that the computations are stable. And so this is all handled by Light here. And then finally, for a bit more advanced use is like the strategy. The strategy argument in LightningLite allows you to select different backends that handle the communication between devices. So this is useful when you have big models that need to run on multiple, or you have like a big data set and you want to speed up your training and you need to use actually multiple devices. Then depending on the model you're using, there are different strategies how you can train that. And so there is the simple DP that is useful when you run in a Jupyter notebook and want to use multiple GPUs. Then there is the standard DDP that PyTorch recommends for most applications. It also works with multi-node. And then there is the sharded training that can save you memory by doing some magic with the optimizer states. They typically take a lot of memory. So if memory is a concern for you, then maybe try DDP sharded here. Or for very huge models that don't even fit the parameters into a single GPU, then there's also this awesome library called DeepSpeed, and it's well integrated into Lightning here. So, but this is more like for the future if you really get into big models. And finally, LightningLite, as I mentioned, is only a part of a bigger library called Lightning. And eventually, if you do a lot of deep learning, probably you want to level up in this library. So LightningLite will probably not be enough for you. You want to have many more features, and that's something that Lightning can provide. So when it comes to boilerplate code, there's not just boilerplate code only for accelerators and distributed training. There's actually a lot of boilerplate code that people write around checkpointing, logging, and all of this stuff. And this is where Lightning really shines. It takes away that burden for you, and you find a lot of useful features in this library that are just perfect for deep learning deep learning engineers and researchers. And yeah, for the docs, if you want to learn more, if you want to see tutorials from beginner to advanced to expert, everything is there in the docs at docs.pytorchlightning.ai. And yeah, with this, yeah, thank you so much for listening. We can now open it to questions. I see there are